Before you can mine for gold, you've got to know what kind of rock you're digging in, right? Well, it's the exact same idea with data mining. The very first step, the most crucial one, is understanding that data comes in all sorts of different shapes and sizes. So let's dive in and see what those actually look like.
To really get our heads around this, let's use an analogy. Let's picture that all the data in the world isn't just some chaotic cloud of ones and zeros. Instead, imagine it's a massive, sprawling library. Every single piece of information has a place, but not every place is the same.
So this is basically our map for the tour. We're going to start in the most organized, well-lit sections of this data library, and then we'll venture into some of the more complex and, frankly, more interesting specialized wings.
Okay, first up, the basic forms of data. I want you to think of these as the main floors of our library. The places with those neat, orderly bookshelves that are super easy to navigate. Our first stop here is the relational database. At its core, it's just a collection of tables, kind of like a bunch of spreadsheets that can talk to each other. Each table has columns. We call those attributes, and rows, which are known as tuples or records. Every row is basically a single item, like one customer or one product, and the columns describe it.
So, sticking with our library analogy, this is the classic card catalog, right? Every book has its own card, every card is in the perfect drawer, and you can find exactly what you need with a clear, logical system. It's structured, it's reliable, and it's perfectly organized.
All right, building on that idea of organized tables, we come to our next section, the data warehouse. This is where information from lots of different places, say from databases in Chicago, New York, and Toronto, is all brought together into one single central location to be analyzed.
But, and this is important, this isn't just a messy data dump. No way. To build a proper warehouse, the information is processed very carefully. First, it's cleaned up to get rid of any errors. Then, it's integrated so all the different sources can actually work together. After that, it's transformed into one consistent format, loaded into the warehouse, and finally, it's refreshed over and over to stay up to date.
And the result of all that hard work? It's often this really powerful tool called a data cube. It's called a cube because it literally lets you slice and dice the data from multiple dimensions at once. So for example, you could view sales by item type across different cities, all at the same time. It's built for really deep analysis and making big strategic decisions.
Back in our library, this is the special archives room. It's that quiet, serious place where historical records from all the different library branches are gathered, preserved, and organized under one big system, all ready for some in-depth research. Our final stop on this floor is the transactional database. Now, this is all about capturing events as they happen, right in the moment. Every single record or transaction gets a timestamp, whether it's a customer buying something, someone booking a flight, or even just a simple click on a website. In our library, this is just the checkout log. It's a running record of every single transaction, perfectly in order. Simple, super effective, and absolutely crucial for tracking what's going on. So far, everything has been pretty structured, pretty neat. But as we all know, the world's information isn't always so tidy. Not everything can be crammed onto a neat little index card, right? So now, let's venture beyond the main bookshelves. We're heading into the other wings of our library, where we're going to find much more diverse and specialized collections of data. First up, we find multimedia databases. These are built to handle all that rich, complex stuff that isn't just text. I'm talking images, audio files, animations, videos. JPEGs, MP3s, you name it, it all lives together here. And trying to mine this data requires totally different tools. You have to analyze pixels and sound waves, not just words and numbers.
This is the library's cool, state-of-the-art digital media lab. It's this vibrant space just packed with films, music, and interactive displays. All of it is valuable information, but it's in a format that you just can't put on a shelf.
Next up are spatial databases. These are all about location, location, location. They store data that defines a geometric space, using things like coordinates, points, lines, and polygons to represent maps, city layouts, or other geographic features.
In our library, this is, well, pretty obviously the map room. It's filled with detailed atlases, globes, and blueprints that don't just tell you what something is, but tell you precisely where it is.
And then there's the big one, the World Wide Web.
This is, you could argue, the most mixed-up, heterogeneous repository of data that has ever existed. It's a massive, kind of chaotic, interconnected web of documents, videos, music, you name it, all linked by URLs, and it's constantly growing and changing.
Think of this as the bustling internet cafe right in the library's lobby. It's a little chaotic, it's constantly buzzing with new information, and it connects you not just to the library's own resources, but to the entire world outside. Okay, now let's go from the wildly complex web to something fundamentally simple. We also find a lot of text data stored in what we call flat files. A basic CSV file is a perfect example. See, unlike the relational databases we saw earlier, which can link a bunch of tables together, a flat file is just self-contained. It's flat because there's no complex structure, just straightforward rows and columns of data.
Finally, we come to time series databases. And just like the name suggests, these are specifically designed to handle data points collected one after another over time. Think of a stock price chart or weather data tracked by the hour, or maybe server performance monitored every single second. Their whole purpose is just to track change over time.
So we've toured the whole library now, from the super organized archives all the way to the chaotic internet cafe. And this brings us to the most important point of all.
And that is, the shape of your data determines everything about how you can work with it. The methods you'd use to analyze a highly structured database are completely different from how you'd find patterns in a bunch of images or videos. It's like we said, in our library, you simply can't catalog a movie the same way you catalog a book.
And that really leaves us with one final thought. This library of data, it's constantly expanding. New formats, new structures are appearing all the time. So the real question for us is, what new wings and what new special collections are we going to need to build to house the knowledge of tomorrow?